Problems number 23 and 24. The following information applies to questions 23 and 24. A man with a mass M jumps off of a high bridge with a bungee cord attached to his ankles. The man falls through a maximum distance big H, at which point the bungee cord brings him to a momentary rest before he bounces back up. The bungee cord is perfectly elastic, obeying Hooke's force law with a spring constant K, and stretches from an original length of L0 to a final length L equal L0 plus small h. The maximum tension in the bungee cord is 4 times the weight of the man. Questions. Question 23. Determine the spring constant K. Question 24. Find the maximum extension of the bungee cord small h. Solution. Let's use information from this condition. First, we can write equation for energy conservation. When a man traveled height big H down, he used potential energy mgh, and this potential energy turned to potential energy for stretched spring, which is 1/2 k h small square. That's the first equation. Second equation is about maximum stretch of this cord. We have force of tension, which is kh equal 4 times mg. Now let's divide the first equation by a second equation. This will give us that small h equal 1/2 big H. And the last step, we can put this small h to the second equation and find that k equal 8 mg over big H. Let's check the answers. Answer E is good. Answer D is twice less. Answer C is 8 times less. Answer B is 2 times less. And answer A is 4 times less. So correct answer is E. For the question 24, we already found the answer, that small h equal 1/2 big H, which is answer A. Problem number 25. A box with a weight W will slide down a 30 degrees incline at constant speed under the influence of gravity and friction alone. If instead a horizontal force P is applied to the box can be made to move up the ramp at constant speed. What is the magnitude of P? Solution. First, let's do free body diagram. Here we have incline with angle theta 30 degrees, and the forces acting on our block during the motion up is mg, which is force of gravity, force P, which is horizontal force, force of friction, which is going this way, and normal force. From the first sentences we can find out that coefficient of friction equal tangent theta, because this angle is critical for this kind of friction. When body is moving with a constant speed, means that our angle is critical, and tangent theta equal mu. Next step, let's find what is a normal force. From this picture we can find that normal force equal mg cosine theta as usual, plus force P multiplied by sine theta. Next step is to find what is force of friction. force of friction equal mu multiplied by normal force, or this expression. And the last step is to make equation along this incline. Along this line we have P multiplied by cosine theta must be equal to force of friction plus part of gravitational force in this direction, which is mg sine theta. And finally, this is the expression for P cosine theta. And now we can express force P using this equation through this formula. We use mg equal W. We divide numerator and denominator by cosine theta, which will give us expression through tangent theta. We use knowledge that mu equal tangent theta, and after that we have this expression, and the tangent theta equal 1 over tangent theta, which is 30 degrees, equal 1 over root 3, and finally we got root 3 W. That's the answer, D.